Hello everybody, welcome to our second episode in the LabVIEW series. What I believe we're going to do this time is actually start working on a project. So I'm going to start a blank VI so that we can go ahead and get started. Now, before I start, there were some questions about what is the use of LabVIEW, if you will. And even though I don't have an exact answer, it's not as easy to answer as when you're doing HTML or Java or just normal C, because this program is, how to put this? Well, you could get away without using it. You don't need to use it, but it adds a lot of simplicity to what you are doing. In my case, I use it mostly, and I think it's mostly designed to be used for measuring and analyzing information from hardware. In my case, I have used this in Arduinos in the past, and I'll do that along this series at some point. We'll connect the LabVIEW to the Arduino board that I have, and we'll be able to do some real-time things. But for now, what I believe that we will do is some smaller projects that are involved in well, mostly on the computer stuff before we get to connecting it to hardware. So yeah, sorry. LabVIEW is mostly, it's used to take input from hardware and analyze information and create output. It is used in so many applications in the real world. I obviously do not know all of them, and it is not a code that you will find easily. Like it does do FPGA, and you can use it for microcontrollers and all sorts of things, including the Arduino. But those are not mainly where it excels. It excels in measurements and analysis of other tools. So I know, for example, the Lego, the Mindstorm, or whatever they're called, they can be programmed using LabVIEW. Any hardware that you are doing that you want to control through your computer, I would highly recommend using LabVIEW as opposed to any other software. Mostly for the simplicity and the quickness of doing things. Unlike C code, for example, which takes a lot of time to write and is harder to decode, this visual programming, graphical program, makes it much easier to be able to do many things, and the level of confusion, I will say, is less. No matter what, you're gonna get confused, and if you do not know anything about programming, then this is gonna be exceptionally hard for you, I believe, but not as hard as learning C. So I would say this is easier to learn than C if it's your first program. By the way, I think what this code that it uses is actually called G. So yeah, that's kind of cool. Alright, so our first project, what I believe I want to do is a Sudoku solver. I hope you're all familiar with Sudoku. I'm going to go ahead and pull up Paint right there. I love using Paint for easy explanations. So what Sudoku is, in a very quick way of representing it is this diagram, which is basically, it looks like this. Okay, again, remember, horrible at Paint and mouse. If I had paper, this would look much nicer. So it is divided into 9 quadrants like this, and in each quadrant, right, each one of these is further divided into 3 like that. And here there are only 2 or 3 simple rules, and I'm gonna highlight these in red. First of all the numbers in here should be the 1 to 9 numbers. And second, every single column should be 1 to 9, and every single row should be 1 to 9. That's it. Those are your 3 rules to Sudoku. And that's all you need to know to solve it. So basically, each one of these squares should have the numbers 1 through 9, only once, right? So if I'm using, let's use purple. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. There we go. So this is a perfect square. Now these could be in any order, does not matter. But for example, now in these squares right here, these 1, 2, 3, 4, 5, 6 squares, we cannot have the numbers 1, 2, or 3 because they're already present here. So we automatically know that 1, 2, and 3 will be somewhere here or here. And again, this keeps extruding, and this is basically how Sudoku is solved. And I'm going to create a program that you can input the data to it, and it will automatically solve it. Now it's very interesting because if you look into Sudoku, there's a lot of cool things. One of which is actually a very recent study, I believe, that was officially made. And someone discovered that you cannot solve a Sudoku unless you have at least 17, I believe it was 17 initial clues. 17 clues. That's awesome handwriting. So you need 17 clues minimum to solve it. But we're not going to worry about any of that for now. So this is what we're going to do. Now I'm going to go ahead and move on to our actual Labview to start working out with this. So first we're going to need to have a grid. Just as I drew in Paint, we're going to need our grid, which will be, let's see, what do we have here? Not a text. I sometimes have difficulty finding these, so I don't want anybody to feel like I know what I'm doing because I'm not always sure of what I'm doing. Yeah, so perhaps a table. It's not really what I want. Yeah, that looks too complicated. I'm not going to work with this. Alright, so I'm going to do this in a different way, and I hope I will not confuse you guys. So I'm going to start by explaining how programming works in Labview. Sorry, getting confused here. Alright, so what we're going to have is an array. And our array is going to be a 2D array that is made up of, it's going to be a 2D array that is made up, okay, there we go, here are the arrays. This is what I was looking for and I couldn't find it over here. Sorry, okay, so it's in modern, probably under silver, not under the express. So we can find it in classic, system, oh, not in system. The difference between these, by the way, is just the way they look. That's the only difference. This gives you things that look different. But we're going to focus on, I'm just going to go with modern, matrix, and what we're going to do here is an array. So what an array does, and if I, oh, this is not working the way I want it to. We're supposed to have multiples of these. Perhaps there's an option that I can enable here. Let's see, properties. So I need a 2D array. This is a 1D array. And I hope everybody knows what an array is. There we go. So I want a two-dimensional array for X and Y. And I need this to have more... Let's see. Create? No. Add dimension. Add element gap? No. Sorry guys, I'm looking for something specific right here and I can't seem to find it. Yeah, so basically we should be able to change between, we should be able to see all the squares in here, but it does not seem to be happening. Let's see, let me open up this modern tab right there. Look at this, real, I don't want a matrix, I do want an array. Let's try the search function. Yeah, that's not really working. Alright, so here's what I'm gonna do. Again, I hope I won't confuse you guys. I'm gonna go back to our programming list right here, and I'm gonna explain what arrays are. Arrays are very simple, and I'm gonna explain them with Paint. So, an array is basically just a placeholder, and it holds a set amount of data. I'm gonna call it X for now. So I'm gonna call our array X of n, right? So what we would have is we're going to have the first one, x0, the second one, x1, the third one is x2, fourth one's x3, fifth one's x4, and this goes on to infinity, right? So this is our array right here. That's the first number, second, third, fourth, fifth, and so on. So basically, yeah, sorry, this here is supposed to be a comma, not a black line. This is a comma. These are separating the numbers right here. So this is a 1D array. So simply a set of numbers. And this x, right, this could be anything. Anything. Cursive is ridiculously impossible in Paint. So yeah, so this could be anything right here. And the only rule that I remember is that all the elements need to be of the same type. Alright, so same type. In this case, if I put a word here, or a letter, a string in the first one, that means this entire array is set to include words. So I cannot include numbers in between, unless the number is being written as a text, not as a number, right? Hopefully this is making some sense to everybody. The other thing about arrays is that they can be 2D arrays. Now, a 2D array is easy to see because it's basically looks like our Sudoku board, right? So we'd have all these. It's ridiculously hard on Paint. I should see you guys. You guys should open up Paint and try doing this. All right. So basically, this is a 2D array right now. So you can see one. Let's see, there's another color here. You can see 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5. So it's 1, 2 dimensions. And then you can add more dimension. I can go to my 3D dimension, third dimension, fourth, fifth, sixth, which you cannot really draw on Paint or any software. But they exist. You could do them. It just adds to the complexity. Once you're familiar with the 2D system, the rest make more sense. And they are excellent ways of storing information, right? They're excellent for storing information. So what we need right now is a 9 by 9 array, right? So it's going to be 9 in this dimension and 9 in that dimension. So we need it to be 9 in this dimension and 9 in this dimension. That's a Sudoku board. Something that is very, very important, yeah, I'm not going to write important. It's very I, that's for important, is that the first digit is the 0th, right? It's the 0th. And then the second is going to be the first, and then the third is actually the second, and so on, right? So we always start with 0. All right. So let's go back here. So what we're going to need to do, and if you look at all these arrays, there's many things to do. What we need to do is this one, initialize an array. And if I click on it, you'll get the help. Remember the help, Control H, tells me. So this creates an n-dimensional array in which every element is initialized to the value of element. So I'm going to place this here. First thing you notice is that this here does not create anything in the front panel because this is not, and I repeat, this is not an input and is not an output. It is not a control. It is not an indicator. This is just a function in the code that has absolutely nothing to do with the user. This is part of the coding, not part of the input or output. So only the things that are relevant to the input or output of the software or program that we're making in general go on the front panel. Otherwise, we don't care about them. So this will only show up here in the block diagram. Now, what are these points? So when you put the mouse over it, you see there's this orange, blue, black, and these two small blue squares. And it's very important to understand all this. For the orange, blue, and black, you could see those here. This is the element. And as it says here, that this is the initialized value is going to be put into the element. And then the blue one says dimension size 0, and then goes on to dimension size n-1. Now remember how I said it always starts with 0. So dimension size 0 means it's a 1D, one dimension array. If you are not used to this 0 system, you have to get used to it. It is one of the core things in programming. Us as humans, when I tell you to count to 10, you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But a computer, when counting to 10, counts 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? It counts to 9. So n is 10, which goes from 0 to n minus 1, which is 9. So 0 to 9 is 10 dimensions. So we only need 2 dimensions, which is 0, 1. There's nothing else. You have to get used to this counting from 0. Computers count from 0. Code counts from 0, not from 1, as we humans do. Alright, so... Sorry, I'm drinking some coffee. Alright, so what comes out here, this black one, is the initialized array, right? So basically we're telling it how many arrays we have, how many dimensions we have, I'm sorry, and we're telling it what we want to put in them, the element. Now, this gets more and more complicated, but trust me, if you get to doing it yourself, you will easily start to understand all this, because it's very, very simple. And if you do not understand it, then I recommend you keep trying. If you do not keep trying, you will never get it. Whatever you do in life, this is my recommendation. Keep at it. Keep trying to figure it out in your own way until that light bulb in your head flips on. Because if that does not happen, you will never really understand it. So this little single block has thousands of things that I need to explain. And I'm going to try to do that. But if you don't go and work with it yourself, it's not really going to stick. So, what does this do? Alright, so the element, as I said, is in here it tells you that every element is initialized to the value. So basically whatever I put in here, my array is going to come out full of it. Right? So if I put 0, I'm going to get the array, all of it full of 0. If I put 1, I'm going to get an array full of 1. Now, another thing important about the element, which is not really signified here, but you guys will get to learn this while using LabVIEW, is that the type of the element is important. So if I put in here a number, that means this is an array of numbers. If I put in a string, which is text, then this is an array of text. And an array of text cannot, later on when manipulating it, you cannot insert numbers into it. Remember what I said on the paint file earlier? So basically, an array can only be of one type of things that you can put into it. You can actually put arrays in a way, but we'll get into that later on. So that's what the element term is mostly used for. The other thing here is the dimension size. Now remember I said each one of these, here you see 3 blue lines, and I said this is how many dimensions you want. Obviously the easiest ones to explain is going to be 1 dimension and 2 dimensions, which is 0 and 1. We won't get into more than that for a long time. But the dimension size is basically how big it is, right? So imagine you have a 1D, just 1D, right? And you want to put numbers from 1 to 10. That means your dimension size is going to be 10. I know I just told you that computers count from 0, but if this is a size, and size cannot be 0. Well, it could be 0, which means it doesn't exist, right? So a size of 1 means that there's only one square, one element in there. Size of 2 means 2, size of 3 means 3. I'll give examples to further explain what I mean by all this, but I'm hoping I'm making sense. The last thing here is this little thing here, and you see these are dotted, and what this is that you can actually extend, if you click and drag this blue, you can extend the number of dimensions, right? So this is the simplest 1 dimension. Here you have 2 dimensions, I have 3 dimensions, 4 dimensions, and it keeps going on and on, right? There's some differences to this, and we'll get into those soon. What I'm gonna do now is create a 2-dimension right here. You see that? 2 dimensions, and I'm gonna go ahead and start filling this out. So the element here, I can right click, create a constant. It's the easiest way to do it. And I can say I want to fill it up with the number 10, for example. Does not really matter. And then here we have the dimension size. So I'm going to create a constant for each one of these. Create constant, there we go. So let's say I want a 2x4 array, right? So this is literally a 2x4 array of 10s that just came out over here, right? Now, if I want to see this, array, what I need to do is create an indicator. And an indicator will show up on the front panel. There it is. Here's my indicator. This is what I was trying to get earlier. I just realized my mistake earlier. Why this didn't work the way I wanted it to, right? So the problem was that I did not set the element type. I'm going to go ahead and rewind for a second, and I hope I don't lose anyone while doing this. Remember when we came here and we did modern array and we put in an array, then I right clicked, there we go, right click property, there we go, right click properties, and I set the size to 2 dimensions. Now the problem is I set the dimension that I want 2 of these. I obviously didn't set the size, but I needed to set the element type. In this case, we're using, see there's text, we're using numbers. So I would need to put a number in here to specify that this is a number, right? That's what I was doing. So now these are pretty much the same thing. This here is just to change between it. I can actually just get rid of it. There it is. Now they're the same thing. So I'm gonna leave this on the side for now. So here's our array. Now this is an empty array, obviously, because we did not run the program yet to get the 10s, right? So what I'm gonna do now is I'm gonna run the program. There we go. So now you see only 1 10, right? This here is the position X and the position Y, if you will. So X, the 0th is a 10, the first is a 10, the second is a 0, right? And then we can do these as XY coordinates. The other thing we could do is we can click this and drag it open to get all the other combinations. I can actually make this smaller as well. There we go. So now you see we have a 2x4, right? So it's a 2x4 array full of 10s. Now these, to further explain them, this is the 0th row, this is the first row, and then this here is the 0th column, first column, second column, third column, right? Does that make sense to everybody? So this point right here is the point 0, 1, 1, 0, 1, 2, 3, 3. So this is the point 1, 3. So I'm going to set this to 9 for now. And then if I make this smaller, and then if I go 0, and then 1, 2, 3, and then 1, 3, 1, 3 is 9. If I make this bigger, we have zoomed in to this point. We go back to the 0, 0, and we're back here, right? So this is 0, 0. This is 1, 0. The thing to understand is that this is not X and Y. This is going to be the row 1, row 2, row 3, and then column 1, column 2, column 3. This is the only way to be able to understand what the higher dimensions are when you reach them, right? I believe I saw this information somewhere, and it was really, really interesting. So it goes like from row to column to, I think it goes up to page, and then they all have names. Each one of these dimensions has a unique name, which I actually, sadly, I do not know what the names are of all these. Yeah, sadly, I don't know what the name of these are. Alright, I'm gonna delete this for now. And what I'm gonna do is I'm gonna get this array, which I just made. I'm gonna make this smaller. and I'm gonna make it bigger. Now this is an endless array which I can fill with whatever data I want, right? I can fill this with whatever data I want. It's right here. This here is it's giving me an output just like this. So I cannot connect this to this because these are both outputs and this is giving me an error, right? So it's very important to understand the difference between an output and an input because they are fundamentally different. And I'm gonna make this here and try to give it a similar shape. There we go. So trying to give it a similar shape. There we go. There's a slight color difference, but that's no problem. It's very important to see that this is an output while this is an input, right? Output, input. Because basically what's going on here is that this thing's annoying me. There. So basically this has the triangle on the right, this has the triangle on the left. This is going into this array, this is coming out of this array, right? And now this one is connected to this system. So when I run it, it's gonna give us our 2x4 full of 10s. Now normally we want this to be all zeros. So this 2x4 full of zeros right now. This one here, as I mentioned, is an input, right? So the user tells it what to do. And then this will be translated to nowhere at this point, right? Something to understand is that this block right here is connected directly to this thing here. That's why when I double click here, these two are the same part. You have to understand that they are the same exact block. All connections, all coding, everything is done here on the right side. On the left side is simply for the user to give input and output. It serves no other purpose but input and output. You have to understand that. You cannot do connections here because connections here make no sense. Because connections are what are used to process information from input to output. So the information goes, for example, input here, the player can put an input, let's say 5. That 5 will travel through this block. Now remember, this block and this block are identical. So this block has the 5 in it right now. And this number here can flow, be altered, processed, and then show up on the output. So I'm going to take this, I'm going to put it here, and I'm going to connect these two. So now what I did is I connected this block directly to this block, right? So again, this block connected to this block by this line. So this is the input, this is the output, this wire is the processing which is made in the block diagram. Now if I run this program, this will become identical to this. And I'm going to run this continuously so we can do many things. I could add the number 4 here. As you can see, there it is. I could come here and add the number 2. I could come here and add the number 5. Come here, add the number 6, and if you notice, it's changing with me, right? Now you might ask, why are all the zeros here? Well, the zeros are there because they are used. And what I mean by used, and I'm hoping that's not a very confusing term, but by used, I mean that we're actually used this space, right? So we have identified what this is, and therefore you cannot essentially get rid of it because it's already used. So if I put something in this square right now, all these will be filled up automatically because the column number has been increased everywhere, right? So that's another thing to understand about what's going on here. Now, as I said, we're only gonna need 9 from here, 9, 9, right? And then, so we're not going to need these 3. I can actually take this and make it smaller. It does not matter. I am not selecting a size. That's another thing that's important. Because when I open this again, oh, not this one, this one, right? The data is still there. Even if you don't see it, it is there. It is saved in the array. This array can be opened up to infinity. It is limited by how much of it you use. So you do not need to. So here, by the way, as you can see, okay, I'm going to get rid of this line connect this back here and run it. We set it to 2 by 4. That is not the absolute setting, okay? I'm gonna run it again. I can add a number here, for example, and it will add it to the array. Now, me doing this serves absolutely no purpose because this is an output. This block is an output, right? So the next time I run it, everything I did here is just gonna be disappeared, and it's gonna go back to whatever the code tells it to be. Not like this input. This one will never change because this is a user input, right? So basically I tell it what to do. This one here, the top block, is telling me the output of my code. Very, very important to understand these concepts, especially if we're gonna do something like a Sudoku solver. All right, I hope that all this explanation has helped. I'm gonna go ahead and end this episode here for now. And hopefully next time we'll be able to get deeper into how this works. Just as a final show and tell, I will set this to 6, for example, and run it. And you see now it's a 6 by 4. And it could be a 6 by 9 if I wanted to. There's a 6 by 9. I could even add a third dimension to it, right? And there we go. Let's give it a size. Let's set the third dimension to 3. There we go. Now you see that this is no longer working, and the reason is that this array is 2D. So if I go into its properties and I need to increase it to a 3D system for it to be okay. Now it is a 3D system. Now how does 3D work? I'm gonna set these to like 5, for example. There it is. Now you will notice something very peculiar that just happened. What you're seeing here is, it is a 693, but what you're seeing here is at the point 0, 0, 0, you're seeing the 9 by 3, not the 6, right? But the 6 is still there and you can access it. But the 6 is on a whole different page. This is how it gets more and more complicated. So the 3, which is gonna be your X, the 9 is your Y, and the 6 is your Z. It works in reverse. Another way to look at it, 3 is gonna be your column, 9 is gonna be your row, 6 I believe is page, but I'm not entirely sure that it's called page. So what I'm gonna do is I'm gonna convert this to 1 to signify page 1. And then if I go to page 2, this is page 2, this is page 3, this is page 4, and this is page 5, and that's page 6, right? I could add pages if I want, but they are not initialized. We only have up to 6, which is the number 5 here, right? So these are all pages. I wish there is an easy way to explain this, but there isn't. I'm gonna try to do this really in some kind of way using Paint really quickly. So basically, first imagine you have a sheet of paper, right? This sheet of paper is the first is 2 dimensions, right? You have the columns, and then you have your rows. Those are 2 dimensions. That's the first one. Now your third dimension is like taking multiple pages. That's your third dimension, right? This is your 3D. And I can call this, you can call this, if you want, a book. So a book is 3D because it has many pages, and pages are made out of lines, and lines are 1D. Now, let's say this is your book. This is the book, right? So there we go. This is your book on whatever subject. And then you take your book and then you put more books next to it, and that's going to be 4D. So now you're talking about, let's say, a library, right? A library shelf. This is 4D, right? Now you have, I'm going to say, on a library, we have discussed that these books here on one shelf, all these books on this shelf our fourth dimension, right? Now the entire, when you put all these shelves on top of each other, you're ending up with the 5D, right? And you guys see how this goes. And then you get multiple libraries next to each other. That would be your 6D. And then you take that and you make multiple rows out of the library, right? Because library has many rows, and each row has many columns. And again, that would be 7D. And then eventually what we have now is an entire room full of shelves of books. And this is a room. And I'm going to call this 8D. And now you get to have multiple rooms next to each other. That would be your 9D. And then you have multiple floors, and each floor is one, so that's 10D. Now you have an entire building, right? Because of all these floors, and then you have multiple buildings next to it. You guys get the picture, right? No one's ever going to use that much data, but that's what it is. And the beauty is, if I go down to the 2D and I add one more number, let's say, to this row, this number will exist in every single other copy in the entire building that we have, which is 10D in this case. Alright? I hope that makes some sense. We're only going to use 2D. We're not even going to go to the book level of this. We're just going to use 2D here. But I wanted to explain to you guys what it is. I hope that made some sense. If not, I'm sorry. I hope this makes more sense as time goes by.